So, welcome class to lesson 6-2. Today, strong mathematicians can find pairs of fractions that add to 1. So take out your notebook, your pencil, you can write down today's date, the name of the lesson, and let's get started. After these box 1 notes, these are a review from yesterday. Just like I said, unit fraction, remember, it represents one equal part of a whole. A unit fraction has a numerator of 1, and the unit fraction is 1 over d, which is 1 of d equal parts, which is the denominator. Fraction number 4, we know 1/6. We know I would say of as well because you've seen the video before. And we're good to go. Fractions, sum of the units. 1 over d. Remember, numerator are some of our keywords. You're going to see numerator still. You're going to see denominator. That hasn't changed. And then we talked about 5/6 is the important part. The sum. We know sum means adding right there. We know this one is really the product. As we've talked about last day, the product of a whole number and unit fraction. There's that unit fraction again, so it's one piece out of the whole. And with that, let's get started today. So there's different combinations to find one whole. As you see on the top bar right here, this bar is exactly one whole. One whole big bar, I haven't done anything to it yet. It equals one whole. But we're going to talk about how there are different ways to get to a whole, which would always be 1. So you have Bob's share and we have Joe's share. So we'll use 2 different colors to show the 2 characters. So Bob might have 1/6. There's Bob. So Bob's share would be 1/6. Plus, then Joe's share would have to be all the remaining pieces, which would be 1, 2, 3, 4, 5, which would be 5/6. And then when I add all those pieces up, notice they're the same as the one right above it. So they would equal 6/6. Or what you see sometimes is 6/6 equals 1 whole. So 6/6 equals 1, which also equals 1/6 plus 5/6. So there's some other combinations. Well, we'll just kind of make Bob keep getting more. So now Bob gets 2, which would be 2/6. Plus Joe's share then would be 1 less, would then become 4/6. But notice 2/6 plus 4/6 equals, you got it, 6/6, which also equals 1, which equals 2/6 plus 4/6. And we'll continue. Bob's share, he's going to take 3 this time, and Joe's going to take 3 this time. Oh, they're going to share. Is that nice? They have the even amount. How nice. They must get along well at home as well. There's 3/6, and there's 3/6, which still equals, wait for it, 6/6, which equals 1. I think probably by now you're getting the hang on. So if you can finish the other 2 before I can, or just pause the video, do them quickly, and then see if your work matches my work. And here we go. We got 4 over here for Bob's share. And we've got for Joe's share 2. Now that I changed up my addition symbol, which equals, and we've got, wait for it, 1 whole or 6/6, because this time we're dealing with 6th. If you have a different number, you might have a different thing, but you're still going to get back to 1. So there is, said Bob's share at 5/6. Plus, and then Joe's share has only got 1/6. Maybe that's how many dishes they do in the house. Maybe how many times they take out the garbage, all that kind of jazz, which would equal 1, which would also equal 6/6. So you can pause the video right now if you haven't, and have all these parts on there to show you all these different ways that we're able to get to a whole based on our drawing of 6. Now this was said we'd be doing the same thing, but without the fraction bars, without that, and just kind of looking at what do they equal at. So if you look, we've got 1 equals 8/8. So notice we're dealing with eighths right now. Well, here if we have 7/8, which means how many eighths do we have left? Notice our denominator does not change, right? If we start with eighths, we're going to have eighths and some more eighths. So you have 7/8 plus, well, if I go 8 equals 7 plus what? That would be 1. So 8/8 equals 7/8 plus 1/8. So nice thing we notice that our denominator is going to stay the same. So if I have fifths, right, this 1, we're going to break into 5 pieces. I'm going to take 2 of the 5 pieces away. How many fifths would you have left? You would have 3/5. Why? Because 5 equals 2 plus 3. See if you do the last one and beat me to it. Hopefully you have by now. We've got 7/7 equals 3/7 plus 4/7. That pauses for dramatic purposes. So you pause the video right now. I think you're trying to get together, like I said, you think about a pizza. You eat so many pieces, someone else eats the rest of the pieces. That means you ate one whole pizza, but you ate different amounts to equal the whole. Here's a fraction bar. Another thing with also once we got how to think about a whole, another part of this unit is comparing fractions. So we have this nice little chart for you right now to kind of look at, and we're going to kind of talk about some things and strategies to help you move on, because you might not have this handy dandy chart sitting in your back pocket or big on your screen. So you have 1/6 versus 1/8. So we find our 1/6. So 1/6 is right, starts here and goes to over here. We have 1/8 that goes from here to right there. So if I look, would I rather have 1/6 of something or 1/8 of something? Well, if it's something that I like, I will have 1/6 of something, because that would be greater than 1/8. I'll just change my color to green right now. We're looking for 1/3. So 1/3 is in green, so it's from here to here. And 1/9 is from here to here, which is a very smaller part. So I'm going to say 1/9 is less than 1/3. And last but not least, we're looking at 1/11. So way down here, 1/11 and 1/12. Notice it's really close to each other. And if I was trying to draw these on my own, they would probably be even maybe the same, maybe even have it wrong. But when I look at this one, since all the holes are the same, 1/11 is greater than 1/12. So you notice the one, if you look at which one has been greater, the one that has been greater has always been the smaller denominator of the two. So we know that in fractions, the smaller the denominator, the bigger the pieces. Notice 1/2 has really big pieces. 1/3, the pieces get smaller. 1/4 smaller, 1/5. So it kind of goes, if I start to draw lines, it goes from here, then here. So you see they keep getting smaller. So the more you cut a hole into, the smaller your pieces become. So you can pause the video, write down some of these things. I really focus on smaller denominator, bigger piece. Heck, I'll write that even down. Smaller denominator equals bigger piece. So I said, I always think of like pizza or something that I want. I always want to get the biggest chunks. I think of what's the biggest chunk? Well, the smaller amount of pieces I have, the bigger the size of the piece. And right now, we're going to put these fractions in order from least to greatest. It's important that you read because it might say greatest to least, which would change your answer to make sure you have it in there. So the least one, which would be the smallest, well, the bigger the number, the bigger the pieces. So the smaller the number, or the bigger the number, the smaller the pieces. So that would mean 1/11 would be the smallest, because that's the biggest of these numbers right here. Then the next would be 1/7. And the last one would be 1/4. So that would be in the order from least to greatest. Andy and Paulo both ordered a small pizza. Small pizza. Said Andy ate 1/4 of her pizza. Paulo ate 1/6 of his pizza. Who ate more pizza? Well, this goes back to I'm comparing two people. So that means I'm going to put 1/4 on one side. And with their person's name to help me out. So here is Andy. And here, Paulo ate 1/6. So now if you look at, we know that the smaller the number, the smaller the denominator, the bigger the piece. So who ate more pizza? Said Andy would eat more pizza. So the answer would be Andy. And this right here would be showing your work, because 1/4 is greater than 1/6. You can draw a line right now. Right box 3, now your turn. I'll get to find different combinations for Missy and Brielle's share to equal 1 whole. So you can pause the video now, work on finding all the different combinations to equal 1 whole. With the following problems, I'd like to figure out what is the missing fraction to make these all turn into 1 whole as well. I like to write out the entire problem, not just the answer, so we really can make the connection between the whole number, how it turns into fraction, and then the two parts that equal that whole number. So I like to write out the whole thing as you do this one right now. So go through and answer these 3 problems. And we have some comparison problems. You're comparing 1/9 to 1/7, 1/4 to 1/6, and 1/10 to 1/8. So do those right now. And we want you to write these from least to greatest: 1/8, 1/9, and 1/5. Said Elena ordered a small pizza. Max ordered a large pizza. Elena ate 1/3 of her pizza. Matt, holy typo city, said, how about Max ate 1/4 of his pizza. Elena said she ate more pizza because 1/3 is greater than 1/4. Do you agree? Ooh, a great question. Why or why not? I'm excited to hear and see your answers for that one. As always, if you have any questions, comments, or concerns, feel free to write those down or share those out. Also, if you have any strategies that you use, feel free to include those as well to help other students in class. And thank you very much for another great lesson.